Okay, so welcome. This is the FHIRPath presentation. I think the round after this will be the last one. And then, of course, the closing keynote still and the drinks to bid you farewell. So, after that excellent keynote, of course, my presentation will probably not impress you as much as those ladies did, but that's okay. I really thought that was a really great talk they had, the way they presented that. So, for this session, FHIRPath, I'm Mirjam, I'm from FHIRly, and well, I've been part of the team since almost the beginning of FHIR, fortunately. So, and I've also been lucky to be at most DevDays. Usually Ewout does this presentation, so for me it's the first time at DevDays that I do this. But what I'm going to do is tell you about FHIRPath, tell you a little bit about what we do with it, and also hopefully show you a little bit of a demo in order to see some FHIRPath. FHIRPath is a navigation and extracting language. So you can use FHIRPath whenever you have data that you can represent as a tree, and then you can use FHIRPath in order to point to a certain point in the tree and extract the values at that point in the tree. So that's why you use FHIRPath for. FHIRPath is a separate standard, so it's not part of the FHIR standard. And that's what you see on this slide. You see that it says STU1 release. That's the release of the FHIRPath standard and not related to the version of the FHIR standard. So this is a separate thing, a separate language that you use. And you can use it with FHIR, hence the name, but you can also use it with other things that have a hierarchical structure as well. So as I said, you can navigate to points in the tree, and in FHIR this is used in order to define search parameters. If you are going to define your own search parameter, you will have to fill in an expression, and that expression will be a FHIRPath expression. The standard FHIR search parameters also have this expression, so again, also a FHIRPath expression. What we also use FHIRPath for is to create more complex constraints when we are going to use profiling. So if you create a profile and your requirements go beyond just setting cardinalities and changing types or choosing the types that you fill in or create value set bindings, then you can formulate those requirements with a FHIRPath expression. And I'm going to show you some examples of that. Also, as I said, it's an extracting language, so what you could use it for is to implement a narrative generator. Then if you get the data, you point or extract certain parts of that data, put it in your text template, and then you can fill the resource.txt with that generated narrative. And as I already said, even though it's called FHIRPath, you can also use it for other types of data that are structured as a tree. Here's an example of some search parameters where you can see a FHIRPath expression. In this case, these are a couple of search parameters from the patient resource type. So you will see that you can have an expression like this, really simple, patient.active, but the last one is already a little bit more complex. There's a little bit more syntax, FHIRPath syntax there. Extra constraints, we call them either constraints or invariants. That's a term that you can use interchangeably in FHIR. You can find them on almost each resource type as well. And if you look beneath the structure, you will see these kind of constraints. They have an ID, and then they also use a FHIRPath expression in order to convey that extra rule I talked about. So those extra, more complex requirements that you might have. So navigating the data in with FHIRPath, well, in this case, as you can see, I've got a patient resource, in XML, but the format doesn't matter, of course. That's my patient resource. It's got some data inside according to the FHIR patient structure. If I would represent this in a tree, you can say, okay, well, we start at the top, we have a root node, and that's just a patient, so that's my starting point. And then from there, you can see that we have the several fields as nodes represented in this tree. Some of those nodes have values. So for example, you can see some values filled in here. And other nodes might have subnodes and no value. With the FHIRPath expression, I can then select parts of this. So in this case, you can see my FHIRPath expression over there, patient.name.given. You don't necessarily, by the way, have to mention the root node, because that's implied, that's your starting point anyway. Well, to be complete on this slide, I have set that. So if I would use the FHIRPath expression patient.name.given, then I would look at this tree, and I would walk through that from the top to name, and then to the given fields inside. This FHIRPath expression will then result in this set of given names. So this is what I get when I use that particular FHIRPath expression. I could also, as I said, have used name.given. And if you are somewhere in the tree other than on the root level, you can also just walk from that point in the tree if you know what the underlying elements are. You can also use functions within FHIRPath. So in this case, I'm going to take a look at navigating by axis. So for example, well, we still have the patient. I could say I want to have the patient.children. And then I get the direct children of that patient node. So that's the top ones that are in red now. I can also say I want to select all of the descendants of this particular patient. So then you will get a patient.descendants, and this will be, in the end, a collection of all of the nodes that you see in red now. So in this case, just all of the nodes that are beneath my root node. Then I can also select parts of it. So in this case, my FHIRPath expression that says descendants.use will look at all of the descendants of this patient and then look at whether there's a use filled in, and then that's the value that I would get. So in this case, I would get that use with the value official. I mentioned collections already, and that's because in FHIRPath everything is a collection. So when you use a FHIRPath expression, the result will be a collection. Can also be an empty collection, of course, if there's no resulting data from your expression. But if you have these collections, you can then do some work with them. So there's some predefined functionality in the FHIRPath specification for that. So for example, you can see that we have patient.name.count. So that will first select patient.name. That can be a collection of multiple names, and then you can do a count of them. So of course, that in the end will result in some number value, but also that number value is again a collection of one number value. And you can also do nice stuff like patient.name.first in order to get the first one. If you know in FHIR we have all these lists, and well, sometimes you're just interested in one single value, and then with things like first, last, you can get that particular one value out of there. So in this case, my second FHIRPath expression here will indicate or will select the first name and then the last given name from that first name block. Well, if you do that on something that is not a list, so for example, patient.active, if you ask for the first element of that collection, that will be the same as just using patient.active, of course, because there's no list. So there's just one. We can also filter, and this is one of the expressions that you saw in one of the example slides at the beginning. So I can use the where function and then fill in an expression in order to indicate what I'm interested in. So this expression here says, I'm interested in patient name blocks where the use is set to official. So this will select, well, actually it will select that name. So you will get back that name, including all of the data that's inside of there. But you will know that that's a name that has the use set to official because of my expression. And of course, if there was another name in the list of names that also had the use official, it would be selected as well. But in this case, my other name doesn't have that value. So what's also useful is the tests that you can do. So in this case, we have, for example, the empty function in order to test whether a resulting collection is empty. Of course, the other way around, you can also test for existence. The exists function can take a criteria as well, so I can just check whether identifier exists as in my patient resource or in my resource that has identifiers. But I can also check for existence of this official identifier. So if I use criteria, then, well, of course, that is taken into account, and these functions will return a true or a false value. Sometimes you will need that, because if you are going to create complex constraints inside of your profile, those constraints need to evaluate either to true or false, so to a Boolean value, because a validator will take that expression and then test the data against that expression. And of course, well, a validator is interested in either it's valid or it's not valid. So that's why you have to have an expression that evaluates to true or false. So these existence type of functions, they are quite often used for that. You also have Boolean operators, but please know, because we also have empty sets, you have more complex logic than just true, false, ands and ors. But on the FHIRPath specification, you will find a table just to indicate what is the result of what when you and or XOR the things. Comparisons are also possible, of course. So think about having a birth date, and you also always will want to know that this is before the current day or on the current day. Then you can use the normal comparators in order to do that. And there's lots of functionality to manipulate strings as well. So the data that you get out of it, you can check that against a regular expression, for example, or you can just take a subpart of the string and test that. So that's all possible with FHIRPath. Then, as I mentioned, FHIRPath is also used, next to in the search parameters, in profiling for the extra, more complex constraints. This is a screenshot I took from an observation where you can already see that there's a list of constraints, and you just see the description of those constraints partly here. Those are constraints that are already predefined by the FHIR specification. But of course, you can create your own as well. So as I said, you want to have an expression that will evaluate to either true or false, because then a validator can check against that complex constraint. And here's some examples what you could check. So I mentioned the birth date. It must be on or before today's date. In this case, we would look at the birth date element, of course, and look at the value there. So that's just one single element that we're looking at and then checking against a certain, now in this case, the date. But the other one, if a cholesterol value result is not available, you will have to use the node field, it should say, because in R4 it's node. STU3 it was still called comments. Forgot to change this one. When we are going to create a formal constraint, you will declare that on the common parent of the elements involved. Or of course, if you have just one element involved, you can put a constraint on that particular element. So I'm going to give you an example of that in a minute. But once you've identified what the common parent is, or the node where you want to put that constraint, you will have to think about a key. That's just a unique identifier for your constraint. Every constraint already predefined also has a key. Perhaps you saw that on a previous slide. It says, for example, OBS-1 for the first one for observation, etc. You also will be able to select whether, whenever this requirement is not satisfied, whether that's an error or a warning. Because sometimes you just want to give a warning. Oh, did you think about this field or about this particular requirement. It's not a hard stop for me, but I want to indicate that you might check your data in order to see if you have more information. So you can say it's a warning. But of course, well, the most commonly used is the error, because you have a requirement. If it's not satisfied, then the data does not comply to your profile. So let's take a look at this particular constraint that we have here. If we don't have a cholesterol value, then we have to use the note field. So this actually says nothing about the use of both. So I can fill in both of these fields, right? And if I take that a step further, you can think about, okay, that will mean that they can't be both empty. And now we've got something that we can put in some formal expression, because I just mentioned the empty and the exists functionality in FHIRPath. So in FHIRPath, this could translate to value quantity should exist or node exists. These are two fields within observation, and perhaps you know that observation can take multiple values, value types. So in this case, I've specified that I want to have a value quantity. So it would not be sufficient for someone to just fill in a value string. I'm really interested, or my requirement is to have either a quantity or a nodes field filled in. Yes? Yes, you can also check for any value, yeah. Yeah, so this was just my requirement, and well, I think a cholesterol value usually is a quantity, so that's why it says that. But of course, you can formulate an expression with just any value as well, yeah. So, as I said, we have two elements involved here, the value field and the node field. So we will have to check what the common parent of these fields is. Well, if you check the structure of observation, you will see that will be the observation node itself. So my constraint should be put, in this case, on the top level, so on the observation level. That's where I'm going to define my key and my expression, and also an error message for when it's wrong. And then what I also will do is, from the value x field and from the node field itself, I will put a condition on there. And this is not necessary for your validator, but it's good for rendering, because then the renderer can say, oh, if you look at this field, there's an extra attached to that, an extra rule. Have you seen in the FHIR specification that sometimes behind the field you see a capital I behind them? That means invariant. So that means on that field there's an extra rule, or that field is involved in an extra rule. So this last one is how we do that. We, on the value field and on the node field, will say there's an extra rule, so the renderer can show that, and people looking at my profile will know that on that field we have to take care on that field. So the validator will check the constraint that's on this common parent, and the condition is then set on the elements involved. Oh yeah, this is my tree structure, so those are the two involved. Well, it's not the complete observation structure, of course. I had to do some snipping, otherwise it didn't fit, but those are the fields that I put my condition on. And well, in this case, you can see the capital I here on the value as well. There is already one predefined condition on there, so I could check that if I wanted to. So this slide, well, the links are not clickable, but this slide is taken from the link on the bottom. So when the presentations will be made available to you, you can check that. There's some known implementations for FHIRPath. I'm going to show you in a minute the FHIRPath tester. And I also want to show you an example of having this constraint on observation, and then what a validator can do with that. So you will have some examples there. So this is for you for trying it out later. So are there any questions at this point in time before I do my demo part? Good question. The question is it extensible? Can we add extra our own functions to the FHIRPath language? Yes, you can do that. So in the FHIRPath language, it's specified how to create your own functions. Of course, you still will have to implement how these functions then perform, of course. But yes, you can do that. Okay, so a good question as well. Can we compose a new object with FHIRPath out of all of the data that's there? The answer actually is yes. FHIRPath itself will not compose the object per se, but you can with FHIRPath, of course, extract all of the data values you want and then put them within any structure you want. I've been to a presentation where they had this UI with the MVC pattern, so you would have this page with template things in them, and they actually used FHIRPath expressions in order to fill these parts and then show, for example, a nice HTML page filled with the patient's name, etc. So in that sense, you can use FHIRPath to construct your own object. It's also possible with FHIRPath to make a concatenation of a couple of expressions, and then you will have a set of data. But it does not transform the name of the elements, for example. Don't know if you've been to the GraphQL presentation of Graham. It's a little bit different, FHIRPath, from what Graham told about that transformation thing. So you'll still have to do some work yourselves, but yeah. One of the things I can mention is that we use, in our Vonk server, we use FHIRPath in order to index on certain search parameters. As I said in the search parameter definition, the expression is in there already. And we use that expression in order to, when we get data incoming, to get the values out and put them in a nice index table. So that's a really, nice, simple example of where you could use FHIRPath as well. Any more questions? I don't know the answer to that. So I don't think I understand the question well enough in order to answer that. But perhaps we can have a conversation afterwards, so you can tell me what you're looking for, and then okay. So let's do a small demo then. Yeah, it's a bit slow. Got some things running, so perhaps that's the problem. So one of the things I was talking about is that you can create your own complex constraints on your profile. So, for example, what we had on our slides, that you can fill in or have to fill in either a value quantity or the notes field. You can put that on your code. So in this case, you can see that I've got my constraint list here. If I click one open, you will see that this is just one of the normal FHIR constraints. It's called DOM2, I don't know. I can check the expression, and I can check the description in order to know what this is about. But what I did is create my extra constraint, and you see it here. So I filled in a key. That's something you can just define yourself. As long as it's unique within this structure, then you're good. So I've just called it Mirjam1, and I've set the severity to error, because, yeah, in my requirement, it's an error if you don't fill them in. Then this is my expression, which was on the slide as well. And then what you also have to supply is this description, and I've just created a nice English language text here that says, okay, please provide either a value of type quantity or a note. The text that you fill in the description can be used by the validator in order to convey what was wrong. So that's a really important one. It's a mandatory field, so you will have to fill it in. But think about what you put in there, so you can convey to users of your profile or to validators what the idea was of this particular constraint that you put on there. So I filled these fields in. Now I have a profile, so I can use that profile in my validator. And what I did is upload this profile to my server. And now I can, on my server, validate resource instances against this profile. So that's where I have prepared my Postman. And in this case, I have an observation, and you can see that I've set the meta profile to some kind of canonical URL. In this case, that's my own observation profile for the DevDays. So I've created that, and I never bothered to change the example.org, but of course in real situation you would use your own domain there. So I say that this observation conforms to my profile, and that was the one I showed in Forge just now. And of course, in Forge, I've created this complex constraint. And now I send this to my server to the validate operation in order to check whether this is a correct one or not. So that worked, but since I have my screen a little bit enlarged, you didn't see it right away. The validate operation performed correctly, but the 200 doesn't indicate that there are no errors, because just the performing of the operation went okay. You don't know without looking at the operation outcome if it really was successful, but fortunately you see that yes, this was successful. If we look at my observation data, then you would also be able to see that there is indeed a value quantity, and I even filled in a note as well. So in this case, I have both of them filled in, and yes, that fulfills my requirements. I can also show you that this can also go wrong, of course. Oh, this is already the result, but let's scroll up a bit. So I can post another observation, and you can see that in this case, well, I have filled in a value string. Well, why not? I can try this, and if I validate this against that same profile, well, you'll see that I didn't lie. This outcome is, again, just the outcome, and it does say that there's an error. And in this case, where you see the text, you see that I failed a certain constraint, and you can see the key that I invented myself, put on my profile, Mirjam1, and also this text, please provide either a value of type quantity or a note. So that's the description I gave in my profile for the validator to use and convey the error message there. Well, you probably believe me if I just only fill in a value quantity, that then it's successful again, or only fill in a note. I don't have to show you that. But this is an example of where you can use FHIRPath constraints when you do some profiling. So that's one of the things that I wanted to show. Another thing I want to show you is that there's something called a FHIRPath tester. Thanks to Brian Postlethwaite. This is his GitHub. He has created a really cool tool to test your FHIRPath expressions. Well, it's open source, so you can just download it. It's .NET based, so you need to have Visual Studio in order to be able to work with the code or look at the code. But there's also releases that you can use, so you can just use it on your machine. You can run it if you have Windows. So I downloaded this one, and I can run that. I had to download it because I wanted to enlarge the font a little bit, otherwise you wouldn't be able to read anything. So I clicked on Start there. Sorry about that, takes a little while to warm up. As you can see, it indicates that it can support either version of FHIR, so DST2 until R4. and it loads with an example patient value, and on the left you will see an example expression. So in this case it's a concatenation of two expressions, and well, this second one doesn't do anything, so I'll just take this off. If I do this, then I can click on extract, and then it will tell me something about what happened. Doesn't do anything. Oh, there it is. It's a bit slow. So you can see, in this case, my expression will result in a Boolean value because it is a comparison. So it will check the value of birth date in this case. And well, as you can see, the birth date value is set to 1980. And yes, that's before the day of today. So that evaluates to true. So my FHIRPath expression will extract this as a true value. Or I can also say, okay, do a validation. And this is actually then the value a validator would see. It's evaluating to true. So that would make my expression fulfilled. I can also just copy in another example here. So this is a little bit of a more filled in resource. So again, I can use this same expression and see whether this is true or not. Well, okay, it evaluates to true again. But I can also say, okay, I'm interested in all of the given names. So I could say, oh, okay, give me patient.name.given. If I say extract now, as you can see, I get a whole list of strings. Because I selected given, I get these strings because they're just lists of strings. If I had selected patient.name, well, I can do that, so you can see what this will do. Well, apologize for the not formatting of the things, but you can see that I get human name objects, and then they contain all of the fields that are available for human name. So you can select whatever you want out of that tree, and you can do comparisons. As I said, you can also perform matches against regular expressions if you want to do that. So, well, let's see if I can still do it correctly. Oh no, this one, where? Hopefully this results in something. Okay, so now it matches something with a capital J. Of course, this is not a real nice regular expression. You can make that more complex if you know about regular expressions. But as you can see, my list of strings is a lot smaller than it was before because there was Peter and something else as well, I think, inside of the list. So this is what gets out of my resource there. Please note that once you use this FHIRPath tester, you always start at the root node. So, well, in this case, I could have eliminated patient, that's okay. But I always start with this tester from the root. If I put my expression in my profile, and I put it somewhere down in the tree, you are in a different context because you're on that node further down, and that's your starting point. So it could be that your expression is smaller, that you have to leave out the front bit of that expression because, for example, I could already be on given and then test something there. So that's just something when you're going to do some profiling to keep in mind. I've ran into that problem that I just tested it in the FHIRPath tester, put it as a constraint out on my resource, and then it didn't work. And if you haven't heard that before, it takes you a while to realize what you've done wrong. So you have to think about the context. Where am I, or where does the validator start looking from in order to evaluate the expression? So those are the things I wanted to tell you and show you. Are there any more questions at this time? Yes, one. I'm sorry?
A URL like the search API, patient/ID.
No, there's no API on this tool. This is just a tool that you can run on your local machine. So you will have to do that. I don't know if there are any servers that can evaluate an expression. Well, they internally use FHIRPath expressions, of course, for the validators. But you know of one tool or no? No. So this is just a standalone tool. The code is in there. I said it is an open source tool, so you can take a look at the code and then see, for example, or if you could create a command line tool that does the same thing, but then specifically on command line instead of in a Windows-based frame. The code is in there. The code, by the way, in this case comes from the .NET API, but of course also the Java library has a FHIRPath evaluator as well. Yeah, okay, thank you, David. So the ClinFire has a FHIRPath evaluator on the patient view as well, right? Yeah, okay. Thank you. Well, that's it for me. Thank you for your attention. And hopefully, well, we'll see each other at the welcome drinks. Come say hello or come say goodbye. Hopefully, also I'll see you in DevDays Cleveland or perhaps next year DevDays here in Amsterdam. Hopefully we can continue this event. I wish you a good time for the rest of the day. And again, thank you for your attention.